NASA found a planet the size of Jupiter that weighs almost nothing. If you could drop it into a giant bathtub, it would float like a ball of candy floss. Right now, its own star is peeling it apart, layer by layer. This is science crumbs, where we make the universe make sense. Grab a snack or a drink and let us dive into this very confused planet. Imagine you are holding a planet the size of Jupiter. Now, what if I told you it weighs about as much as a bag of marshmallows? No joke. This thing is so light, you could fill a swimming pool with it, and it would bob on the surface like a pool toy. That's not just wild, it's almost rude to every science class you ever took. Let's talk about density for a second. Don't worry, this isn't a pop quiz. Density just means how much stuff is packed into a space. Earth? Packed tight, like a suitcase before a holiday. Jupiter? Still pretty beefy. But this planet, its density is less than 0.1 grams per cubic centimeter. That's less than cotton candy. Seriously, cotton candy is about 0.05 grams per cubic centimeter. So if you could somehow scoop up a chunk of this planet and plop it on a dessert table, it would blend right in with the candy floss. It's so fluffy that if you made a cube of this planet the size of a car, it would weigh less than the actual car. Picture that at the dealership. I'll take the planet, it's lighter on gas. And here's the kicker, planets are not supposed to be like this. We grow up thinking planets are these solid, heavy balls. Even the gas giants are supposed to be, well, giant and heavy. But this one? It's like the universe tried to make a Jupiter, got distracted halfway through, and just left it puffed up like a party balloon. Scientists actually had to double check their math when they found it. The numbers looked fake. It's as if someone swapped out a planet for a cloud. So what is holding it together? Why has it not just drifted off or gotten torn apart by its star? And how do you even measure something that is basically a cosmic marshmallow? Turns out those are real questions astronomers had to ask. So next time someone says all planets are big, tough, and heavy, just remember the universe has a sense of humor, and sometimes it makes planets that are basically space candy. Weighing a planet made of fluff is not simple. Astronomers turned to the transit method, watching as the planet crossed its star and blocked a portion of the light. The dip was enormous, comparable to Jupiter, and it implied a planet of impressive size. But when the team tried to pin down its mass, the numbers refused to cooperate. Using radial velocity, they searched for the star's subtle wobble, the gravitational tug that reveals a planet's heft. In this case, the star barely moved. The signal was so faint, it was almost lost in the noise, suggesting a world that looked massive but weighed next to nothing. The math was relentless. Density was less than 0.1 grams per cubic centimeter. That is lighter than milk, barely above cotton candy. A piece the size of a soccer ball would weigh less than the ball itself. NASA and the James Webb Space Telescope team checked and rechecked, convinced something must be off. But the data held. The planet was real, and its fluffiness was no illusion. Orbiting just 0.05 astronomical units from its star, about 8 million kilometers, the planet is 8 times closer than Mercury is to the Sun. Its year lasts only 8.7 days. At that distance, most planets would be stripped bare, their atmospheres blasted away by relentless heat and radiation. Yet this one remains swollen, its puffy envelope somehow intact. The numbers defied every expectation. Planets this light and this close to their stars are not supposed to keep their atmospheres. The rules say it should be a naked core by now, the outer layers long gone. NASA and the James Webb Space Telescope team pored over the evidence, each new calculation raising more questions. How could a planet so large, so insubstantial, and so close to its star still cling to its airy shroud? The mystery deepened with every answer. The planet's existence challenges what astronomers thought they knew about how worlds form and survive. The puzzle was not just its size or its mass, but the fact that it endures, floating in defiance of the forces that should have torn it apart. Imagine a planet so full of hot air, it is literally leaking into space as we watch. No, this is not a prank. NASA's James Webb Space Telescope, JWST, has been peeking at this cosmic marshmallow searching for proof that it is slowly deflating. And get this, scientists are looking for helium. Not the party balloon kind, but a super specific version that glows at exactly 10,830 angstroms, a weird number that just means a shade of infrared light. Why helium? Because when a planet's atmosphere is getting blasted by its star, the outer layers heat up and helium atoms get so excited they start escaping. If JWST catches that helium signal, it is like seeing the planet's skin peeling away, one layer at a time. Picture a giant, invisible hairdryer blowing on a ball of cotton candy until wisps start drifting off. That is what is happening here, except the hairdryer is a star and the cotton candy is the planet's outer shell. In 2025, JWST aimed its sensors right at this puffy world during a transit. A transit is when the planet crosses in front of its star, and some of the starlight shines through the planet's atmosphere. If even a tiny bit of helium is escaping, JWST's detectors can spot it. It is like catching a thief in the act, except the thief is helium and the loot is the planet's own air. Scientists at NASA and the JWST mission team spent nights glued to their screens, hunting for that helium fingerprint. Every blip in the data could mean the planet is actively losing its fluff right now. If you ever wanted to see a planet caught red-handed losing weight, this is it. And the best part, it is all happening live, right under our cosmic noses. Picture this. A planet so light it is literally leaking into space, like a soda can left open in the sun. Scientists call this process photoevaporation, but honestly, it is just a cosmic sunburn. The star's energy blasts the planet's outer layers, heating them until atoms start floating away. It is not a quick pop like a balloon. Think more like a slow fizz, millions of years in the making. One day this planet's puffy shell will be gone, leaving behind only a small, dense core. Here's the wild part. This is not just a one-off. There is a whole group of these so-called superpuffs scattered across the galaxy. They are all giant, fluffy, and hanging out way too close to their stars. Scientists have even spotted a pattern, what they call the evaporation valley. It is a kind of cosmic gap where you do not see many planets with half-missing atmospheres. Instead, you get a bunch of puffy, oversized planets on one side, and a bunch of stripped-down, shrunken worlds on the other. Like a before and after ad, but for planets. So, what is really happening here? These planets are caught in the act of changing shape. Over time, their thick, airy envelopes get blown away, and all that is left is a rocky or icy heart. Some of the small, scorched planets we see today might actually be the skeletons of once fluffy giants. It is like finding out your tough old coffee table used to be a marshmallow. Looking at these puffy worlds is like flipping through a time lapse of planetary evolution. The universe is not just making planets and leaving them alone, it is constantly sculpting, stripping, and reshaping them. Every superpuff is a snapshot, showing us that even the weirdest planets have a story, and sometimes they are just passing through a very awkward phase. Right now, scientists are watching this puffball planet melt in real time, like a marshmallow left too close to the campfire. It's a front row seat to how worlds get made and unmade. Out there, the universe keeps throwing us curveballs. What will it toss at us next? Drop your wildest guesses below.